All right, describing a method to estimate the quantity of garbage in the Great Pacific Garbage Patch. This question has come from a resource booklet, and so the grade boundaries I've used for this exam are like the resource booklet grade boundaries. So you have two papers in the exam. You have paper one, which is your resource booklet and questions, and that's more similar to the kinds of questions that are in here. And your last exam was short answers and essay questions. So that's like paper two. So you're starting to see all the different styles of questions. That said, and I will repeat this to the whole class, this was a very hard exam because we've put together all the hardest parts of the ESS syllabus pretty much into this exam. And so I have modified the grade boundaries by almost a whole level in order to accommodate that, all right? So to make it fair. Because in the actual exam, you're going to maybe get one of these calculation style questions and another one on methodology, right? It's not going to be the whole exam. So let's have a look here. So describing a method to estimate the quantity. This was I think 2013 resource booklet. And my students were studying ESS at that time, and it really freaked them out because they were thinking like, well, how can you do sampling of something that's not alive? But of course you can. You can do sampling of anything. And this can even be an IA looking at litter, right? So you've got this patch of the ocean, and in it, there's plastic. If we assume it's a homogeneous area, then we could basically take samples in random areas of that plastic. Now remember, we're talking about not like a grassland where you can just put these flat, but this is three-dimensional. So it really helps if you talk about taking these samples, these standardized sample sizes at multiple depths. Then you don't have to do a quadrat, right? Some of you talked about, I think it's the Harmon grab. So this was one of the tools that we researched in class. But you could just use a net as long as it's of a standard size. So you're using the same net every time. So it's systematic sampling. And then you're going to random locations that you've determined. You talked about then taking out, like maybe counting or weighing, so get the mass of the plastic. You talked about drying, which is a really good idea, right? You don't want to weigh it with all the water on there. You talked about extrapolating, so then like taking the average. And you talked about extrapolation. So it's really, really similar to that biomass question earlier on in the exam. It's exactly the same principle. What you can't do for this is a mark recapture, right? Because the plastic, you put the plastic back in, the plastic is only following currents. It is not moving by itself. It is not interacting with its community. It is not mixing. And remember that for the Lincoln index, you have to mix. You have to mix everything up. So that's not happening with plastic. And so you cannot do Lincoln index, a mark recapture, because it will be biased, very, very biased, okay? Nice thinking, but I can't give the mark for that. So any 4 points on here were accepted. And yeah, I think I'll talk about Lincoln index later when we get to the fur seal example. I'll talk more about that. But this one is more like sampling of a homogeneous area. Okay, on to part B. Okay, so this question, I really wanted you to think about respiration. What is respiration? So respiration, I mentioned it earlier in the exam, it's glucose plus oxygen, and that is going to make carbon dioxide and water, okay, plus energy. Okay, so if the animals are ingesting plastic instead of their natural food source, they are not getting glucose, and therefore they are not getting energy. And that is the essence of their starvation. Yes, they can get the plastic stuck in their digestive systems. Yes, that will cause them to starve. But this question asks you to talk about it in reference to respiration. Okay, so we want to get at this concept that respiring is how we get energy out of food. It's not about how we breathe. How we breathe is how we get oxygen into our system. How we respire is how we break down the glucose into these components that are released and then energy. So the number one point, there were 3 marking points that you could have said. So any 2 will give you the mark. Can't get glucose out of plastic is 1. No enzymes. So, I mean, in theory, a bacteria could evolve over millions of years that could digest plastic and that could turn it into a compound that it can use. But the organisms are animals. Animals do not have enzymes that can digest plastic, so they cannot make glucose from it. Nobody said this, but that was a possible answer. And the final one, so no glucose. If you said something like nutrients, so I took nutrients, so they weren't getting nutrients from their food. I took nutrients to mean glucose, and so I would give the mark for not getting enough nutrients. So that would just be 1 mark, right? So 1 mark. So I wanted you to get to this process. If you didn't say anything about respiration, you could not get 2 marks. So if you just talk about nutrients and then you went on and talked about, digestional blockages and things, you would just get 1 mark. Okay, is that the last of question? Yes. Okay, so on to the next video.